Next up, we have Nate Anderson, Director of Marketing from Resi. Nate, do I got you here? I saw your camera earlier. It was pretty cool. Um, do we have Nate? There he is.
Hey guys, sorry about that.
Oh, you're good.
All right, hey everybody, welcome. Thank you so much. My name is Nate and I work with Resi. If you haven't heard of us, we provide ultra reliable live streaming technology that takes a little bit of a different approach. And we started out with a desire to get from video from one point to another, and with no failure even on intermittent network connections. And so in order to achieve this uninterrupted transmission, we started with costly and complicated solutions like dark fiber, dedicated MPLS circuits, satellite, stuff like that. And in a lot of cases, these systems were out of reach or impractical to us and, of course, a lot of other users. And our aim is to provide the reliability of these solutions in a format that's accessible to any organization. So we have two solutions. We have our Resi live streaming solution and our point-to-point solution, or multi-site solution, which we call it. And they provide the reliability of dedicated connections through 100% frame accurate video delivery resiliently over public internet connections. It can withstand complete internet outages at the encode site or the decode sites with no interruptions, and given extended outages, we'll just continue to retransmit that video when the connection is resumed. In fact, I can even go ahead and unplug my Ethernet cable from my encoder here, and viewers won't even notice a thing once I plug it back in. So I'll demonstrate that. You'll actually be able to see that happen in just a few minutes. So, first question obviously is, how does this work? And the secret is through our patented resilient streaming protocol, hence our name Resi. And in the end, it's really not that complicated. I'll actually show a little animation here in a second. We just take advantage of a short delay or predefined amount of latency. So our encoders cache all of our video content locally as they're encoding, which is why we produce our own hardware. And as the video is sent to the cloud verifies every frame with the encoder to make sure that it's received with full integrity. So if for whatever reason the content is disrupted, or if I decide to pull the Ethernet cable out, for instance, the encoder will continue to resend any content that was missed. And if that interruption is less than your predefined delay, then there will be absolutely no interruption on your stream. Viewers online or at remote locations will have no idea that a disruption even happened. And in most cases, this is what happens, right? We know that the internet's not a perfect place. It's a mess of wires running all around the world. And it's filled with packet loss, buffering, stuff like that. And Resi protects for these natural interruptions and makes sure that your viewers get an uninterrupted online experience. And if your connection goes out for longer than your delay, that content is still being stored locally at the encoder. So viewers' video will be temporarily paused, but all content will be stored locally, and it'll continue to be sent once the connection is resumed. Once the internet is available again, each frame will be sent and verified with the cloud in perfect order, and the stream will resume from where it left off, ensuring no content is missed by your viewer. So I'm going to share a kind of a helpful illustration here between Rtmp and RSP. And as you can see, Rtmp works like a laser beam. So it's sending packets of data to the cloud in a single connection. And when this connection is interrupted, the content is simply not available to viewers, and these viewers or these frames are discarded entirely. RSP, like I was saying, obviously takes a different approach, and that it communicates with the cloud, ensuring that even through network loss, video content will be stored locally, verified in the cloud, and resiliently delivered to viewers. And I'm also going to share a little video comparison of RSP and Rtmp in action. And this is actually from a Spartan race, which was broadcasted side by side with Rtmp on a cellular connection.
Maybe that's pushing the pace early, as well as Ryan Kempson and Ryan Kent, who we mentioned before.
Look at Woods. He is setting a very, very quick pace to start off with.
So smooth.
And Atkins is right there. He's not letting them go. Atkins is in 6th place right now. He just started up that little berm.
More than anyone, Ryan Atkins will run his own race. He will not let them Dickens. I have a few. That's Mark Batris, maybe. That's pushing the pace early, as well as Ryan Kempson and Ryan Kent, who we
So that's pretty
before.
cool. You can actually see the comparison there side by side.
A very, very quick pace.
Of course, we know that latency and delay can be an important factor for streaming, and we understand that. And whether you're streaming to multiple destinations or to the web, there are ways to control the amount of latency that you're using to consider the need of low latency versus the reliability of your current connection. And for our live streaming solution, our minimum latency is about 90 seconds. For a point-to-point or multi-site solution, it's about a minute. And we've really tried to strike a balance here between providing a level of resiliency that live streaming engineers desire, along with typical latency needs of an event. However, we also recognize that typical latency, that our solution will not be the perfect need for the use cases for everybody who needs a very, very short delivery time. So we are perfect for, however, is where a little bit of latency or delay is okay, but perfect delivery is demanded. So let's talk for a minute about our different solutions. Our most popular solution is the Resi live streaming platform, and this takes advantage of Resi's RSP by saving video content locally to your hardware or software encoder and transmitting it to Resi's scalable CDN. It can also be distributed to destinations like Facebook and YouTube, and it's available through HLS or Dash URLs for implementation into other platforms, OTT devices, and more. So I have two of Resi's hardware solutions right here. We have our Resi server grade solution. This is actually our decoder, but the encoder looks the same. It's the same form factor. We also have our Resi Ray, which is based off of an Intel form factor. And this one is great for where you might want a low cost, more portable option. And all of our hardware encoders include SDI inputs. Our server grade models also include HDMI and can be configured as single or dual channel, and single or redundant power supply as well. We've also recently introduced our first software encoder, which you can see here. And it offers the same benefits of our hardware encoders, but built into your own computer. And because we're very popular with many churches, house of worship environments, we've also built it into existing software that many of them are familiar with and comfortable with, which is a software here called ProPresenter. So you can see on my screen here, I'm going to start outputting. This is a really cool way to be able to take your camera input in, be able to stream with the same benefits of Resi. If I enable my display there. Oops. There it is. You can add lower thirds, graphics, titles, all that good stuff, and then be able to stream out to Resi from the same source using your own hardware. And setting up and scheduling Resi is super simple. You can see our control here. Once you've plugged in your hardware or set up ProPresenter, you can set up your schedule through control for any events you want to broadcast. You have the ability to start your encoder along with your web events or as a separate event. So I can go here into my scheduling. I can say schedule events, live schedule, type in my schedule description, and then start my encoder independently from my web events if I'd like. And then that way, we have the flexibility to preview our content locally or send it to other physical decoders. You can also add your web events independently, choose your destinations from here. So we can add all of our social media destinations, stream URLs, HLS, Dash URLs from there. And then once we are done setting up our schedule, we'll hit save and it's done. So really simple, really easy to use. And you can sit back and relax knowing that your content will be transmitted exactly when and how that you intend to. And if you do have issues with your connection, Resi's Cloud will automatically notify you. So we can set up your contacts in here. And we have proactive streaming alerts that will immediately notify you of any issues. And these alerts are also sent to our support team. And they are monitoring all week long should you have any questions. And once your stream is done, video content will be saved to your library within the cloud, so you can store that and use it later for sharing, archival, and distribution. So let's transition to multi-sites or our point-to-point solution. And you can see here the same encoders are used for the broadcast site, but decoders are used for playback at an unlimited number of receiving sites over the cloud or decoders on a local area network circuit. This solution works similarly to the live stream platform on the first mile, but it has one key difference in that your latency is not a static buffer, but it is instead dynamic depending on when you begin playback at your receiving sites. Video is cached locally at the encoders and then sent to the cloud where it's verified, and decoders will request this video from the cloud and include their own local cache to store content and protect the integrity of the connection at receiving sites. This means that you could lose your internet connection for as long as the delay between encode and decode and still have perfect playback. So if you're streaming at 9 o'clock and playing back at 9:05, I could actually physically unplug my Ethernet cable again from my decoder here. And as long as I plug it back in before that delay is up, before about 4 minutes, and all of the content that would be displayed with no interruption. So this means that you have control of starting this playback when you're comfortable. If you have a better connection, you can be comfortable with less of a delay. If you have a worse connection, you can add a bit more. And regardless, Resi will ensure a full video transmission, just like you have a direct connection between your campuses. And most of the time, these decoders are run over standard internet connections. Our protocol and the way that we upload and download will take care of any of the interruptions that occur. And as mentioned, we also have the ability to run them in LAN mode where the decoder is set on a local area network or a direct connection like an MPLS circuit. And in this case, you have the additional advantage of video content being sent directly from the encoder to the decoder and skipping the cloud. However, it also transmits to the cloud with cloud failover so that the direct connection So if the direct connection is disrupted, the decoder will simply pull the video from the cloud instead. And unlike our encoders, which run headless, decoders utilize a monitor, keyboard, and mouse, just like you see here, for playback and local control at receiving sites. Decoders include a single or dual SDI or HDMI out and are configurable with single or dual power supply units and Genlock inputs. Now, I have a system set up here. It's actually routed into our video router before it comes back to these monitors. And for some reason, it was working up until about 30 seconds before we went live. And then now I'm not getting video display on these monitors. So I might not be able to show this off for you today. But regardless, you can check out a demo of it if you go to resi.io/demo, and you can actually see it in action. But I'll have, typically what we show off is a dual channel event transmitted from a dual channel encoder. What's cool about that is you can use it for 2 video channels however you want, perfectly synchronized. So whether that's a virtual speaker on with an IMAG shot, clean and program feeds, graphic feeds, or any other video content. You can also send and receive up to 16 channels of audio through SDI, through embedded SDI, and often receiving sites will use this to send ancillary audio from their program feeds, such as timecode, producer mic, comm, or click track. And this keeps receiving locations in perfect sync with the broadcast site, which is pretty cool. So Resi's multi-site solution is a really powerful tool for point-to-point video delivery with unmatched reliability and flexibility. And it's been a really cool to be able to see it in some really unique video workflows. Including one opportunity where we had the chance to broadcast between 2 Royal Caribbean cruise ships, and we'll share a short clip from that.
We are currently on one of 2 of the largest cruise ships in the world, owned by Royal Caribbean. This is the Oasis of the Seas, and her sister ship, Symphony of the Seas, are both chartered for. Obviously, you're in the middle of the water. There's no fiber, there's no SDI, there's no hardline network between the 2 ships. So we're dealing with satellite. A project like this is difficult on a ship because we were doing calculations before and we were going roughly 57,000 miles to transmit to a ship that might only be a mile away. So we're going from Oasis of the Seas to a satellite to Peru, fiber to Miami, fiber to a transcode server, back to Miami, back to Peru, up to satellite, down to a satellite on Symphony, just to send a file one direction. Without the hardware backbone and support provided by Living as One, there would be no clean way to send video from ship to ship, sailing next to each other in the Caribbean.
I honestly walked in sort of skeptical, not of Living as One, but just of the entire process, because it's pretty crazy to talk about linking to moving ships over internet, especially over a pretty limited bandwidth internet that can go in and out based off of cloud cover. And so I had some skepticism on the whole process in general, but things actually were incredibly smooth. This morning we had an issue where internet outage happened, cloud cover came in, and so we had a drop in internet for several minutes there where it was kind of looking like, hey, we had total packet loss. But true to name, being lossless encoding. When we did get internet back, things started coming back, and we were able to keep rolling as planned. Didn't have to adjust any planning, anything like that. Obviously had some backups in place, but we didn't have to use them, so that's a great plan.
Working with Living as One on the ship has been a great experience. Being able to record, playback, encode, decode, and provide VOD to the guests on each ship so everyone can watch content anywhere has been awesome, and it wouldn't work without them.
We lost no sessions that I'm aware of. We got all of our content transferred. We didn't have to delay any start times. We didn't have to change any programming around. And in fact, we were actually able to use it to even adjust and correct a few things that happened live in room before we would rebroadcast them. We were able to actually make some corrections. And so, yeah, it worked great.
All right. So as you can see, we've been able to use Resi. We used to be known as Living as One, by the way. I was going to mention that before the video started, but we've been able to use it in some really cool use cases, and I'd love for you to be able to check out a demo of it, resi.io/demo. We have demos, like 3 demos a day, so you're able to actually see the platform in process. You can see both the web solution and the multi-site solution. Just for the sake of fun, though, I'm going to show you unplugging my Ethernet cable from my encoder. I also bypassed my decimator, so we'll see last minute here if I can get my decoder demo running. But plugging back in my Ethernet cable, and if you show my laptop screen there for a second, within about 90 seconds here, you'll see the stream keeps going with no interruptions, which is pretty cool. So that is all that I have to share for you today. Thank you so much for joining us on this demo, and I'll pass it back.
Thanks a lot, Nate. I had a question. So you guys created RSP. Can you talk about that a little bit? It's pretty interesting.
Yeah, so it's our own protocol that is built upon MPEG Dash, but it uses an application layer that is doing the integrity verification checks in the cloud. So we're taking each frame as it comes into the cloud, checking with it, making sure that it's perfect before we send it to receiving locations or to your viewer that's watching in the cloud.
Gotcha. That's pretty cool. I was reading about that when I first saw that you guys were there. So what was your former name? And you know, when you guys first started, what kind of got you guys to where you are now?
Yeah, totally. So it's a really good question, and actually, I just got this monitor working again. I wasn't able to get it into our router, but you'll at least be able to see it in the camera shot here. But we started. Our first name was actually Living as One, and like I mentioned kind of briefly in the introduction, we started actually out of one really dedicated use case, one use case that we had, which was we had a church house of worship environment where we needed to get it out multi-sites to multiple locations. But all of these locations were in varied areas around the Dallas, Texas area, and a lot of them were in schools or theaters or places like that where internet connections were just going to be hard to come by. And so we had different situations where we maybe had a decoder that was set up on a 5G hotspot, or we had one going through really wonky Wi-Fi connection or something like that. We've also had them used in prisons, which has been a really cool use case where we've had certain events, Global Leadership Summit, other church events, God Behind Bars programs, stuff like that, where they just simply needed to get video out from one main location and get it somewhere else reliably, with very limited connectivity, obviously, in these jails and prison centers. And so we've been able to use the use case for that. And after we developed that program, we started getting more varied requests for uses for it, stuff like Toyota, Spartan Race, Chick-fil-A, companies like that. And we said, Living as One, this is kind of our original founder's intent, was living as one for all of these different locations and these different churches and kind of unifying them. And we said, it sounds kind of like a marriage conference. I think we need a better name. And so that's where we kind of chose Resi as a call out to our namesake, which is RSP, which is our resilient streaming protocol that we created.
Well, it's interesting because, I don't think a lot of people really understand this. It took me a long time to understand this, but it sounds like, okay, so you're solving with your technology a first mile problem, right? You're solving a first mile problem.
Yeah.
Then you're also solving what a bunch of people would consider an ECDN problem, right? You're actually an ECDN for internal LANs, which, believe it or not, a lot of large corporate organizations have this issue, right? There's some companies that solve it, but it sounds like, you solved kind of that first mile, and then the entire eCDN piece, and then created a platform around that, right?
Correct. Yeah. So the first mile is really what we saw with our live streaming solution, which is let's get every frame to the cloud verified perfect integrity. And then that solves getting all of that video. Once we have it in the cloud, then we know that it's perfect. And then our last mile of getting to wherever our other point is solved by the fact that we have these decoders, which essentially just do the same thing in reverse. So you can see I've got this display here. This is my dual channel. A lot of venues would like to do this sort of thing where they might do like an IMAG shot, but then they'll also do, you know, this kind of virtual speaker cool thing here. And the other thing that a lot of people love about our platform too is we not only provide the video delivery, we also provide all the metadata to go along with it. So you have the ability to transmit up to 16 channels of audio, which has been really helpful for some of these, you know, corporate events where you might want to send time code and synchronize your playback and do, you know, different queues that are based on time code at receiving locations. We also have this concept of queues or queue stack. And what's cool is you can really put anything that you want in here, and you can say this is my start of program, this is my end of program, this is when the speaker sneezes, any of that stuff. All of that shows up to all of the receiving locations. So literally your playback for the receiving sites becomes as easy as we go in, we hit go to on a queue, we hit play, and then it's playing. So it's really as simple as that.
Got it. So it's actually a playout. It's a playout solution as well.
Correct. Yep. Playout from the decoder that runs with monitor, and then the encoder solution is entirely headless.
Great. This has been great. Thank you, Nate. Thank you so much.
Thank you.
It's been great to watch. I don't have any questions for the panel, but I asked all the ones I had, and I'm definitely going to be checking out your platform. It's pretty cool. Prize, we are giving away a prize. Eric is hitting me up. Resi's giving away a prize.
Yes.
And I think I'm supposed to give that away, right? Is that how that? Oh, Bernardo Gonzalez is the winner. Okay, Bernardo Gonzalez, you are the winner. Congratulations. What did they win, Nate? Can you tell me?
They won one of our little Resi Ray encoders, the little portable one that is based off the Intel form factor, and we will get that to you, very soon.
Congrats, Bernardo. They'll get an email with info. Bernardo, you'll get an email with info, but congratulations. And thank you, Nate, and the team at Resi for showing off everything you got today.
Yeah, thank you guys.